good evening. Here we go again. More applications. These applications are coming out of Chapter 5, Section 5. This is still applications based off of quadratic equations. Everything we see is quadratic equations. This is course hack, page 521, I believe. Page 521. It's after the one that we just did yesterday. So here we go. Number 1. I'll give you a couple seconds so you can get this up. Just joking. If you needed to wait, you can actually pause, and then you can pull up your course pack, and we'd be ready to go. So, on dry asphalt, the distance d in feet needed for a car to stop is given by this equation. The distance is equal to 0.05 s squared, where s is the speed, plus 1.1 s, where s is the car's speed in miles per hour. What speed limit should be posted on a road where the driver's round a corner and have 80 feet to come to a stop? So we're modeling distance using this equation. Realize what I was just told. I was just told that I have a distance of 80 feet, and that's equal to 0.05 s squared plus 1.1 s. There's my equation. The distance is 80 feet. I have the stopping, ignore that bell. I have the stopping formula that I need to use to figure out how long it would take me, I have the formula that will show me what speed I'm going to stop in 80 feet. So I need to find the speed. I could try to do this by hand. I could subtract 80 from both sides, make it equal to 0, and try to use the quadratic formula, but I think it's easier for us at this point to pull up our calculator. If I pull up my calculator, I want to go ahead and plug this into my calculator. I'm going to call the left side, as always, y1. I'm going to call the right side, as always, y2. Bring the calculator back up, hit y equals, plug in y1 to be 80, plug in y2 to be 0.05. I don't have an s, so I'm going to hit x squared plus 1.1x. Again, I don't have an s, hit enter. I plugged in x for s. So at this point, I want to go ahead and graph. And if I hit graph, I sort of see something there, but I really don't see both equations. I need to see both lines in this. Well, let's go back to y equals. I have a y1 of 80 and a y2, looks like it's doing something. So I'm going to hit the window button. And when I hit the window, I need to make sure that my y max goes above 80. So let's make it go up to 100. Let's graph this now. So if I graph this now, there's that first line. There's the quadratic formula, but I don't see their intersection. Notice the intersection is to the left of my calculator. So I'm going to go back to my window, and that means I need to increase my x. Let's make my x, I don't know, let's make it 40. I'm trying to figure something out here, so I'm going to guess a little bit. I make my x 40, and look, I can see where my graph crosses. Here is my intersection. Here is the window I chose to get that intersection. Now I want to figure out what that point is. Now, you're immediately going to say, but yesterday you had the second part, and I wanted to see what that other intersection was too. And you're right, I did. But remember, for all of these, I just need the positive intersection. So I just need the one intersection. So let's go back and find that positive intersection. So I'm going to go ahead and I'm going to hit graph so I can see it. My intersection is under calc, so I hit second trace to get calc. Number 5 is intersection. First curve, second curve, guess. I get 30.48 miles per hour. That intersection right there, the positive one, is 30.48 miles per hour. I'm plugging into S, and I only want positive miles per hour. I can't have negative miles per hour. So S needs to be a positive number. So 30.48 miles per hour is the speed I would need to be going to be able to stop in 80 feet. That's my first example. Let's go on to the next one. This next one, we're talking about maximum values. Just like yesterday, where I was looking for a maximum value, today I'm going to be looking for a maximum value. So, the amount S in pounds per acre of sugar produced for sugar beets can be modeled by the function S is equal to negative 0.0655 n squared plus 7.855 n plus 5,562, where n is the amount in pounds per acre of nitrogen fertilizer used. How much fertilizer should be used to maximize sugar production? S is sugar production. What is the maximum amount of sugar you can produce? So I'm figuring out S as pounds per acre. N is pounds per acre of nitrogen fertilizer I'm going to put down to get S pounds of sugar. So I want to look at this and I want to find my Y. S is going to be my Y. N is going to be my X. And I can plug this into my calculator. So I go to my calculator. I hit Y equals. I'm going to put in a new equation. So Y1 is equal to negative 0.0655 X squared, because it's taking the place of the N, plus 7.855 X, because it's taking the place of the N, plus 5,562. There's my equation. I only need the one equation because I'm trying to find a maximum. How do I know I'm going to find a maximum? I'm going to find a maximum because it has a negative in front of the x squared or n squared term. If it was positive, I could possibly find a minimum. So let's find my maximum. Well, I have to have a graph that will match this. I have a y-intercept of 5,562. So I know I need to go above 5,562 on my y's. My x's, I need to kind of figure that out as I'm going. So let's look at this. I need to go to my window. My x is negative 10 to 40. Let's leave that. I'm not sure when I'm going to need that. But I definitely, though, that my y max needs to be above that 5,562. So let's make it 6,000. And let's graph that. I can barely see the bottom of this, or it should be the top of this. Make sure I typed in the right equation. Okay, so let me go back to my graph or my window and make my x max a lot larger than 400. Let's make it 500, or 40. Let's make it 500. If I graph, wow, that seems to make a lot more sense. I just kind of guessed. When my window was back at 40, I really couldn't see much. It's even going up when I need it to be going down. So I made it a lot larger, and I guessed at 500. And notice it goes up and then back down. It's this point here, this top point here, which is my maximum. And I need to find out what that is. So to find the maximum, I hit second, and I'm going to hit trace to go to calc. The maximum is number 4, so I go down to number 4 and hit enter. My left bound, I need to be the left of my maximum, so I'm going to left arrow over till I'm to the left of it. I'm going to hit enter. I'm going to arrow over till I'm right of that maximum. I'm going to hit enter again. And it tells me that I have a maximum of 59.96 and a y of 5,797.50. Well, what is that telling me? Remember, my x was nitrogen. So this is telling me x of 59.96. This is pounds per acre of nitrogen. Will maximize my y, which are pounds, which is 5,797.50 pounds per acre, but this is of sugar. So this is the amount of nitrogen I need to use to maximize my sugar at this amount of pounds per acre. If I use less, I'm not going to get as much sugar as I want. If I use more, I'm not going to get as much sugar as I want. So I need to use 59.69 pounds per acre of nitrogen to maximize my sugar at 5,797.5 pounds per acre of sugar. That's maximizing. Let's do one more example of maximizing. An agricultural researcher finds that the height h in inches of one type of pepper plant can be modeled by this function. H, the height, is equal to negative 0.88 r squared plus 8.8 r plus 20, where r is the amount of rainfall in inches that fell during the growing season. How much rain would maximize the height of the pepper plant? What is the maximum height? So again, on each of these, I'm finding two questions. How much rain would maximize the height, and what is the maximum height? So again, I go to my calculator. I realize that h is going to be my y, r is going to be my x. I go back to my calculator. I go to y equals, and so y, I'm going to clear that out. Y equals negative 0.88x squared plus 8.8x plus 20. I notice by looking at my standard form that I have a y-intercept of 20, so I want my y values to be greater than that, and my x values I kind of want to guess at. 500 seems kind of big for the height of something in inches, so I'm going to go back to my standard 10 and see where that gives me. My y max, again, I have a y-intercept of 20, so let's go above that and do 30. And let's hit graph to see what this shows me. I see part of my graph, but notice I'm not high enough and possibly not far enough to the right. So I go back to window and far enough to the right. So let's make my x max 20 and not high enough. Let's make my y max, let's double it and go to 60. Let's see what that does for me. So I can see the entire graph. I can definitely see this is the point I want to maximize. So let's find that maximum value. Again, I'm going to go to second trace to get calc. Number 4 is maximum. Left bound, I'm going to go to the left of this point and hit enter. Right bound, I'm going to go right of the maximum by arrowing over and hit enter. Guess, I'm going to go to the middle and hit enter. And it tells me that I have a maximum of 4.999999991 and 42. So that tells me that my x is going to be 5, because 4.9999991 is most probably 5. So if I get 5 inches of rainfall during the growing season, I'm going to maximize my height, y, to be 42 inches tall. That's how I use a maximizing type of problem. Hopefully this makes sense to you. Let's see if I can save this to the right place. Have a great day. I will see you in class.